Hello and welcome to Coffee Table Physics. I'm Riley.
And I'm Jonathan. The reason you're probably here is because, just like us, you wondered how do planes fly?
The answer is this, the aerofoil. No, not airfoil. You see, this is what we're here for, to make the language of physics English again.
But before we get there, now that we've spoiled the surprise, we should first make sure we're all singing from the same hymn sheet when it comes to Newton's laws.
Yes, Newton's laws again. I know, they crop up everywhere, including a plane.
So, Newton's first law, according to a physicist, states that a body travels at a constant speed or remains at rest unless it is acted on by an external force.
Or in other words, an object will keep moving in the same way unless you push it.
That's right. You don't need a net force to keep something moving. Just provide an initial push. Then, as long as there's no net push or pull, the object will carry on in the same direction with the same speed.
So why, when I push this, does it not keep on moving?
Friction. This is the force from the table causing it to slow down. If we remove friction, it would just keep on going. This is similar to the drag experienced by a plane.
Next, Newton's second law states that a body will accelerate when acted on by a net force, and this acceleration is proportional to the force applied.
Meaning, a net push or pull causes an object to speed up, slow down, or change direction. If I double the force, the object accelerates or speeds up twice as fast. We won't need this law for today, but we'll be sure to return to it another time.
And now on to Newton's third law, which states that if object A exerts a force on object B, then B will exert an equal force on A in the opposite direction.
Or more simply, if I push on an object, it will push back on me just as hard.
Now I know what you're thinking, but how do planes fly? I hear you.
So before we start making this sound too much like a school physics lesson, let's get on to the interesting stuff.
So in order for a plane to fly at a constant speed without moving up or down or changing direction, Newton's first law means the plane must be at equilibrium, meaning all the forces are balanced, no net push or pull.
So what are the forces acting on a plane? There are four: thrust, drag, weight, and lift.
Thrust is the mechanical force provided by the engines. Now jet engines work by accelerating the incoming air, producing a high-speed jet at the back of the engine.
Thanks to Newton's third law, this push that accelerates the air backwards causes the air to push the plane forwards, generating the thrust.
The higher the speed of the jet, the greater the thrust force. This acceleration is achieved in four simple steps: suck, squeeze, bang, blow.
First, the air is sucked in using a large fan. Some of the air is directed around the engine and straight out of the back as thrust. The rest enters the engine and is squeezed through compressors consisting of a series of blades, increasing the pressure.
Then the compressed air is mixed with fuel in the combustion chamber, causing an explosion which rapidly heats up the air. The air expands as it's heated and so speeds up. This high-speed air is then directed out the back.
This jet turns turbines at the back that are connected to the fan at the front, and so turns the fan and sucks in more air. So, by squashing and heating, it creates a high-speed jet that provides the thrust.
This balances the drag caused by the air hitting the front of the plane, much like when you feel the air pushing against you when you're cycling.
The lift is provided by the wing.
Yes, we're finally onto the aerofoil.
Here is the essential bit of physics that makes the difference between a plane taking off and pathetically staying on the ground. We'll start with the right answer as to how aerofoils generate lift.
We must warn you that we are then going to discuss some of the most common wrong answers to this question. You'll find these in many physics books, but trust us, they're wrong.
If you don't believe us, ask NASA.
We trust NASA.
And they agree.
So first, the right answer. When the air hits the front of the wing, it splits. The air flowing over the top sticks to the wing's surface, a phenomenon known as the Condor Effect. This effect can be seen when you put a glass under a tap.
When the air reaches the back, it continues to follow the wing's curved shape, and so will be deflected downwards. The air passing underneath the wing is also deflected downwards.
Now, due to Newton's third law, since the air is pushed downwards by the wing, the air must push the wing upwards, and so the lift force is generated.
The wing slows down the air, causing the air to exert a drag force on the wing. Those that support this explanation are sometimes known as the Newton camp.
Now we must also mention Bernoulli. His equation relates the pressure of a gas to its speed. However, unfortunately, his equation has been the basis of a common theory to explain lift, called the equal transit time or longer path theory. But don't be fooled by its fancy name, this theory is wrong.
The reasoning goes that when the air is split, each molecule passing above the wing is somehow married to a molecule passing below. Each molecule of gas going over the top has to reach the end of the wing at the same time as its partner, going underneath, in order for them to be reunited. Since the top of the wing is longer than the bottom, the air on the bottom must travel faster.
Then finally, they use Bernoulli's equation to say that since the air is moving slower below the wing, there must be a higher pressure below than above. This difference in pressure generates a net lift force upwards.
Those that support this are sometimes called the Bernoulli camp, which really isn't very fair on Bernoulli.
Because this is complete codswallop.
Or trash for the Americans.
The molecules are not married and they do not need to be reunited.
In reality, the air on the top of the lifting wing travels much faster than this, and so is not reunited with the air on the bottom.
But they had to drag Bernoulli's name through the mud. Bernoulli's equation can be correctly used by saying that the wing shape squashes the air below the wing and thus the air travels slower, creating high pressure. The air above is stretched, causing it to travel faster and so creates a lower pressure. This pressure difference generates an upwards force. Bingo! We have lift.
Many also drag Newton's name through the mud by using an incorrect theory which applies his third law to just the bottom of the wing. This theory suggests lift is generated by air molecules bouncing off the bottom and exchanging momentum to the wing, giving it a push up and thus generating lift.
But this neglects the truth that both the top and bottom of a wing contribute to the deflection of the air downwards and thus create the lift.
Another common incorrect theory uses something called the Venturi Effect to try to determine the speed of the air passing over the wing. This assumes that air flowing over the top behaves like air passing through a nozzle.
But I mean, come on, it doesn't even look like a nozzle. The wing may be one side of the nozzle, but where's the other side?
Since the air is not confined from above, the air moves over the wing much more slowly than it would through the centre of a nozzle.
And so, surprise, surprise, it's also wrong.
But on the other hand, it does give you an idea of what's going on.
Now, we only have to look at the fact that planes can fly upside down to see that these theories are incorrect. Otherwise, you would get a downforce which would push the plane down and cause it to crash.
Also, the very first plane, built by the Wright brothers, didn't use an aerofoil, funny enough. But they knew what made it fly, the angle of attack. By tilting the wing at this angle, the flow of air is deflected downwards, and so you have liftoff.
So, in summary, the engines provide the thrust to move the plane forwards and counteract drag. This allows the wings to push the moving air downwards, and so the air pushes the wings upwards, creating lift.
Both Newton's and Bernoulli's laws, done correctly, are complete explanations to the question of how do planes fly.
Done correctly being the important phrase.
Next time someone tries to claim that the equal transit time theory is correct, tell them to build a plane with wings like this.
Based on their theory, it should generate lift, as the air has to travel further over the top.
Trust us, it won't.
And so we reach the end. Now, next time you're on a plane, you'll know what's keeping you up.
Thanks for joining us. If you have any thoughts on the video, feel free to leave them in the comments box.
Plus, tell us if there's something about this wonderful world around us that you think, I want to know what's going on here. We would love to help.
So, see you here next week.
Same time, same place.
Cheerio.